Hello everyone and welcome to today's video. I will be showing you how to use the Surface to Truss component, a powerful tool which allows you to generate various truss geometries directly from surfaces. What makes this component very convenient is that the outputs can be directly used with a create linear element and easily integrated into a structural model. Now let's see the component in action. What I've quickly done here is create a basic ruled surface from two curves which I will use as our input for the component. I can find the surface to truss under the Utilities tab of Karamba3D. When I look at the component, I can see that there's quite a few inputs and outputs to this. Let's plug in the surface and see what happens. Actually, nothing happens yet because to generate the truss, I need to define what type of truss I want and the subdivisions for it. I can choose the truss type by right-clicking on the component and selecting Expand Values List. This displays the available options for truss types and allows me to switch between a few variations. To choose the number of subdivisions, I can use nsub and with a slider define how many subdivisions I want. I can see that something's happening, but it doesn't really look quite right yet. And this is because I actually need to reparameterize the surface. By default, the U values of the surface designate the vertical divisions of the truss, while V values correspond to the positions of the upper and lower girder, and subdivides the surface in the U direction. Let's quickly go through the truss types once again. I've got Pratt truss, Warren, Warren truss with verticals, K-truss, diamond, diamond straight, and Firandol. It's possible to flip the directions of the U and V values as well as swap them, and this can easily be done by using a Boolean toggle. It may be necessary to do this depending on how the surface was constructed, but in this case it's not really needed. The input relax angles adapts the position of the cells so that the angles between are as large as possible. If this option is disabled, the nodes on the upper and lower boundaries are positioned at evenly subdivided U values. If the vertical posts of the truss require a predefined direction, the corresponding directional constraint can be specified here at target direction using a vector. The maximum iterations defines the maximum number of steps allowed for the dynamic relaxation of the internal truss angles, while the length tolerance sets a convergence threshold for reaching a stable solution. I also have the damping factor here, which controls the scaling of displacement changes between iterations. These were the inputs, and now let's have a look at the outputs and see how I can apply them. To better showcase this, I quickly added a simple Karamba3D analysis. The first information output provides the info regarding dynamic relaxation. The second output contains the lines, and these lines can be directly inputted into a create linear element component and easily integrated in the structural analysis. What's cool and important is that these lines are organized into branches based on their typology. So branch 0 contains the top beams, branch 1 the bottom beams, branches 2 and 3 contain left and right diagonals, and branch 4 contains the verticals. This data structure comes very handy when you need to assign element IDs, bending stiffnesses, and cross-sections to each beam typology. While flipping through various trusses, variations in the number of branches is kept the same, and this allows the user to test multiple truss geometries without having to change the rest of the script. In some scenarios, like in a Pratt truss, an empty branch can occur, and in this case, a grasshopper native clean tree can be used to avoid any issues that may come with empty branches. Additionally, the orientation of each element along the Y and Z axis is also made available. This offers more clarity for structural interpretation and modeling, and these directions can be used to orientate the beam local directions and thus cross-sections, local loading directions, or hinges. Thank you and see you at the next video.